Hi, this is Pavel with a C# exercise from the book C# How to Program. This is exercise 5, chapter 5, exercise 41, enforcing privacy with cryptography. And we are asked to write a program that accepts or reads a 4-digit integer from the user, and we will encrypt it as follows. We will replace each digit with the result of adding 7 to the digit and get the remainder after dividing it by 10. After that, we will swap the first digit with the third and second with the fourth, and we will display the integer. So basically, if I enter a digit 3, 4, 5, 6, I will now add 7 to each digit, so 3 plus 7 is 10, and then divide it by 10 and get the remainder. So 3 plus 7 is 10, divided by 10 gives us the remainder of 0. 4 plus 7 is 11, divided by 10 gives us 1, the remainder of 1. 5 plus 7 is obviously 12, so it gives us the remainder of 2, and 6 plus 7 is 13, so we get the remainder of 3. Now we will have to swap the digits, so the first one with the third and second with the fourth. So in other words, our third and fourth digit now will become first and second, and our first and second digit will become third and fourth. So the encrypted value will be 2301. And we will write a decryption method that will get this value or any value and decrypt it based on the original encryption scheme by just reversing it. In other words, it will encrypt it back to our 3, 4, 5, 6 or decrypt it. Okay, so let's start. I'm going to, I already created a class called encryption class, and I will also actually create a class called decryption class, because that will be the one that will decrypt the value. So now I will have two classes, and I'll start with the encryption. Okay, so first, the way they want us to do it, I will show you two ways. I will show it. The way I will do it is using strings and using a method of substring to get the each character or each value separately, and I will also do it using actual numbers as integers. And I will show you how to get each digit separately. So for encryption, I will use the string. So we need some variables as always, and that's going to be, we need basically 4 digits. So I will do private, and it's going to be the integer of a private. Oh, I'm out of the class, I'm sorry. Over here. So it's gonna be private integer, and it's going to be first digit. And obviously we'll do the other 3, so it's going to be private integer second digit and private integer third digit, and finally private integer fourth digit. Okay, so now we can do we have to do our declare a class. Our, what is it called now? I forgot. Constructor. So it's public encryption class, and this one will accept the string that the user enters. That will be the value to encrypt, but so I'll call it number. And first of all, we have to make sure that it's 4 digits. Alright, so over here I will do a little method that will check whether the number is 4 digits. Alright, so I will do public, and it will return an integer. Oh, actually no, sorry. It will it will of course return a boolean, and it will simply say whether it is 4 digits or not. So it will check 4 digits, and it will accept the string of the, I'll call it again a number. So when is it 4 digits? Well, remember, this is a string, so we simply can check the length of the string. So if the length is 4, or if it doesn't equal 4, then we will return false, meaning that it is not 4 digits. Otherwise, it is 4 digits, and we will return true. Okay, so over here I will simply check. I will call this method first to make sure that like a little input check to make sure that the number is in a correct format. So I will do if check 4 digits, and I will pass the number that the user supplies to it. So if this returns true, then we can proceed. Else, well, if it's not 4 digits, then we will simply throw new exception, and I will just say invalid input. Now if it is good, if it's 4 digits, then we can assign the value to our first, second, third, and fourth digits. But I will declare property for each of them because these are private, so I don't want to access them directly. I want to use the I want to use the methods and the properties to access those values. All right, so I will do public, and it will be an integer, obviously, first digit, and the property will be as follows. It will return, if you ask for it, then we will return the first digit value, and to set it, we need to this is where we will be using the calculations. So it would be our first digit will equal to the value of the first digit of the string that the user supplied. So I will have to do a method for that will simply split each digit into into 1, 2, 3, or 4 digits. So over here I will do it's gonna be a private because we don't have to access it from outside this class. It will be an integer. I call it split digits, and it will accept the value from the set method in our property, and it will also accept a digit. In other words, it will let us know what digit is it returning, first, second, third, or fourth. So I can come back over here to my first digit property, and I will make our first digit equal, and I will call the method split digits, and I will pass the value, so it's just the value, and oops, it will pass the split digits. Where am I? Equal split digits, yes, and I will pass value. Why doesn't it let me pass the value? Because I am passing it as an integer now, to perform the split, but I accept it as a string. Actually, I didn't accept it at all yet. So over here, I'm kind of jumping back and forth, but in our constructor, let's do our first digit property will equal, and now I will convert it to integer 32, so it will equal the whole number, not just the one digit. It will simply get the whole number. So our first digit will get the whole number, and now we can pass the value. Maybe still not. And why isn't it? Oh Jesus! I'm sorry, I forgot. Wrong semicolon, of course. So how about now? Value, and we will pass the. Since this is the first digit, I will pass the integer 1. And that's because my property is with a. I didn't use the right brackets. All right, geez, that is something. And over here we of course need a semicolon. Man, just a syntax thing. All right, so I have a first digit that accepts the whole number. Let's say 3, 4, 5, 6. Now I pass it over here, and it calls this split digit method with the value 3, 4, 5, 6, and a digit of 1. And the digit 1 we will use to determine whether we are dealing with first digit. The digit second digit will have a value of 2, third digit will have 3, and so forth. So when I go to my split method now, I can perform some splitting that string. So over here I can declare a new digit. I will initialize it to 0 just to start with, and I will convert the number, the value, into a string, because like I said, I'm going to be using string methods to split the number. So it will be value to string. So now it's not a number anymore, it's not an integer, now it's a string, and we have it in our toString method. So I declare a string value. That's our variable, and it now holds 3, 4, 5, 6, which was the input, but as a string, not as an integer. So now I can do if the string value is less than 4, this is done. What we do, I will add 0 plus the string value. All right, now what this does, not string, this is a string value will equal 0. I'm basically adding 0 at the beginning of the string, because let's say if we get a number that's what if we get a number like this, 0, 1, 2, 3. If we get it as an integer, it will dismiss the leading 0, and it will simply say 1, 2, 3. It will be 123. We have to make sure, like, that's why I'm checking for the length, not just the so if the length is less than 4, then we know that the leading number that is missing is 0, that it was simply dismissed by the program, because again it's 0, 1, 2, 3 in the eyes of the program would be 123. It does not recognize it as 1, 2, or 3. So this way we make sure that it contains 4 digits. If it doesn't, we know that we are missing some zeros at the beginning. So now we have that, and our new digit will now equal, and I will convert it back to our integer. Convert that to integer 32. I will convert the string value to it, and I will now be able to return the digit. So our new digit, I will simply return. What's the rule? We have to add 7 to it and then do the mod 10. So we will simply do new digit plus 7 mod 10. So, and it will simply return that one digit. Okay, so I hope you can follow what I'm doing here. Again, we are accepting a value which is 4 digits, or supposedly 4 digits, and this digit simply means whether we are dealing with the digit 1, 2, 3, or 4. We will convert that number, the value of 1, 2, 3, or 3, 4, 5, 6, or whatever, to a string. So now we have character 3, character 4, character 5, and character 6. So over here I check the length of the string to make sure that it's 4, because before we pass it here, the program would dismiss any leading zeros. If it is less than 4, then we add a leading 0 before that value. So now we have a complete string that contains 4 characters, whether it's with leading zeros or without, and we will convert it back to an integer, so we can perform an operation. We can add 7 to it and do the mod 10 as requested. So what I forgot actually over here, what I am converting to digit, I forgot to actually, this is still just the whole number. I need to get just that one digit that I'm dealing with, not the whole number. So over here, the string value, what I'm going to be returning is just one digit. So I have to go to the substring method to get and now where the digit comes to play. So I start with digit as the starting point, -1, because the substring is 0 based, so we have to do -1, and over here it says integer of length. How many characters are we taking? And we're taking 1 character. So for the first digit, this is 1. It will equal 1. So over here I will start 1 minus 1. I will start at the, so if the string is 3, 4, 5, 6, what this means, it will pick this 1 character, 3. It will start as index 0, which is the first one, and the length of 1. So in other words, it will only take the 1 character. Okay, so and I think I forgot parentheses. And now we get that 1 digit. In our case, let's say if it was 3, 4, 5, 6. So now we take 3, just the digit 3. It's converted back to integer. So now we can add 7 to it, which will make it 10. 3 plus 7 is 10. And then do mod 10, or divide it by 10, which in our case will return 0. So our first digit would be actually 0. And now we can do the same with the next, the second, third, and fourth. So I will copy paste. It's gonna be a third and a fourth. So it's first. I will call this second digit, and this will be our second digit, and another second digit, and we will pass a value of 2. So now, remember the substring. If I have the 3, 5, 4, 6, now the value of 2 will mean, if I go to the substring, that it will start 2 minus 1. It will start on the next one. It will start on 4. That will be the starting point. And again, we will take 1 character, so we will pick up the 4. Over here, in our third one, so it's going to be our third digit. It's going to be our third digit, and another third digit. Okay, and we will pass 3. We are dealing with 3. So again, 3, 4, 5, 6. We pass 3 as a digit. So 3 minus 1 is 2. So now it will start over here because it's 0, 1, 2. So it will pick up. It starts from there, and we only picking up 1 character, so we pick up 4. And again, the same with the fourth digit. Fourth digit. 4 and 4, and we will pass, of course, 4. Alright, so we have all of them. Let me see if I made any mistakes. It's first, second, third, fourth. Okay, so that should be all. That should be our 4 digits. Now, let's do the encrypted number, because we have the digits, but we have to swap them now. So I will do a little public string. Again, it will return a string, and it will be encrypted number. Oh, I messed up with the brackets again. Public string and over here we will simply return in these numbers in a the encrypted order. So we will swap the first with third and second with fourth. So first with third, so in other words, we will return our third digit will be our first one now. So third digit, but it's a string, so I will add it to string. Plus our fourth digit will be our second now, to string. Now I'm using pluses, but since these are strings now, all it does is concatenate it digit by digit. It doesn't add them together in a sum. Like it doesn't create a total. It will simply add one digit next to each other. So that will be our first digit, will be our third one, to string, and finally our second digit will be our last one. So now we have an encrypted number. This will return the encrypted number. It will call each of these properties. It will receive the value, one digit for each, and it will put it together as a string. So now we can do our toString method as we usually do. Override string to string, and we will return just a formatted string. So I will do string.format, and I will say encrypted number is, and I will do the placeholder, and the encrypted number will be the whatever is returned from this method. So I will simply call that method encrypted number, and it will return the string with each digit next to each other. So okay, well, let's test that. Let's go to our program and see. So first I will do a string of number. This is what the user will enter. So I will do console.writeLine, enter 4-digit number to encrypt. Okay, and we will do our number will equal, we will have to, we can simply read it because we can use we use in strings now. So it will be our console.readLine. So now we have our number that the user entered, and now we can create the object. But I'll put it in a try method, try catch, because you know, remember, if the user enters less than 3 digits, we will throw an exception. So I want to catch that. So I will go and declare our instantiate our object. I'll call it encrypted, and it will be new encryption class. And we will pass the number. It asks for the, you can see that it asks for the string number. So now we have our object. We pass the number that the user entered to it, to the constructor. And now let's do console.writeLine, and we will simply output the toString method. When we just do the object without calling any method, it will simply output the string format of the object. So it will output encrypted number is, and whatever the number the user entered is. Now over here I will catch the exception if the user enters wrong number, and it will simply say console.writeLine, exception that the message that I already entered, which would be in our case would be invalid input. Okay, so I will have to do the console.readline just to pause the screen. Console.readline, and we can test our encryption. So it's building anytime soon. All right, so let's do 3, 4, 5, 6 like we did before, and we got zeros. Okay, now that's no good. Okay, so let me have a closer look at the encryption class. What did we do wrong? So we got the encrypted number, we split it, we receive that, we have our digits, second, third, fourth. Not really sure yet. And you know what? I don't have. I declared the first digit property in our constructor, but I never did the other three. I created them, but I never actually assigned anything to them. So this is going to be our second digit, and this is our third digit, and of course our fourth digit. Yeah, that's I forgot to, I created the properties, but I never assign any value to them. I have to pass the number to them first. So let's try this again. So 3, 4, 5, 6. 2301 is our encrypted number. And if you remember, that's what we got over here, 2301. This was our original number, this was our encrypted number, and this was our decrypted number. So 2301 is correct. Now let's try something with a leading 0 to make sure that our 0 thing works, and we did get the correct digits. Now remember, we start with our third digit. So our 0 is actually now number 7. Why is it 7? Because we add 7 to it. 0 plus 7 is 7. Mod 10 is 7. The same with 1 plus 7 is 8. Mod 10 is 8. Now 2 plus 7 is 9. Mod 10 is 9. So and that's our first digit now. And 3 plus 7 is 10. Mod 10, we got 0 as a reminder. So this is correct too. Now let's see if I get not enough digits, let's say only 1, 2, 3, and we get the exception invalid input. Or if I get too many digits, 1, 2, 3, 4, 5, I get an invalid input. Alright, so our encryption method seems to be working fine. And now we can do our decryption class. Now, and in this class, I will show you how to actually do it directly with the integers. Before, like I said, we did it with strings, we used the substrings. Now I will do integers directly. So I will simply copy these because we will be using them again. Now this is not the optimal thing. Obviously, if you were using these kind of variables and methods, then there should be some kind of a base class that both of these classes share. But for our purposes, this is, I guess, good enough. So I have the same variables, but they are not the same. Remember, these variables are accessible only in this class. These variables, even though they have the same name, will have completely different values, and they are accessible only in decryption class. So I will do our constructor, so public decryption class. And this time, remember, before in encryption we accepted string. Now I will actually accept the integer, and I'll call it encrypted number. So that's what our constructor will accept. And once again, I will copy paste because I'm going to split the digits again to first, second, and fourth. But this time I don't have to convert them to integers because we are taking an integer in. So this will be integers already. So I will delete the convert to. And I will create the properties now. So I will create a public integer first digit, and it will be, the get is simple, it will simply return the first digit. Now the set will be different for each of these. So the way to do this, you have to look at the numbers that we are decrypting. So now we are decrypting, this was our original input and this is our encryption. Now we have to decrypt it and get back this number. So before that, if it's an integer, look at it like, if it's an integer, it would be, how do you get the first number? Well, basically, if this is an integer, it's not 2301, it is 2301. So in order to get the first integer, all you have to do is divide it by 1000. If you divide 2301 by 1000, obviously you get 2.301. But since we are storing it in an integer, whatever is the decimal, we simply disregard. And the only thing that is stored is number 2, which is the first digit. Alright, so in our first digit, our first digit will simply equal the value divided by 1000. Simple as that. Now let's do our second digit property. Second, what am I supposed to do? Public, of course. Public, and it can be an integer. Second digit. The get is again just returning the second digit, so get will return our second digit. And now our set. Okay, so now let's look at it, what we are getting. Now we need number 4. So basically we will do again 3, 4, 5, 6, but this time divided by 100. And what we will get is 34.56. Now how do we get rid of this 3? Well, this 3, we need to basically do division by, okay, so here, let me do it this way. So over here, oh, I'm sorry, this is not 3, 4, 5, 6. Let me try it again. Let me try it. Now this is our decrypted number is 3, 4, 5, 6, right? So in order to get the 4 or 4.56, we need to deduct 30. All right, so basically what we need to do is do the first digit, which now equals to 2. All right, so let's say our input is 2301. So this is actually not 3, 4, 5, 6. I'm sorry, I'm mixing the numbers. This is our input. Now 2301 divided by 1000 gives us 2. That's our first digit. Now 2301 divided by 100 gives us 23.01. So now we have to subtract 20. How do we subtract 20? Well, we have the first number or first digit, which is 2. So all we have to do is minus the first digit, which equals 2, times 10. That will give us 20. 23 minus 20 is 3.01. But again, the 0.01 will be discarded because this is being stored as an integer. So now we go to our next number. Now we need to get the 0. How do we get the 0? Well, now we divide by 10. What do we get? Well, we get 230.1. So now, how do we get only 0? Well, we need to get rid of 230. So remember, so now we will do the first digit times 100, because it's 200 now, So that will give us 200 minus over here minus 2. So we will 230.1 minus 200 and minus our second digit times 10, which is now second digit equals 2. I'm sorry, second digit equals 3. So that's going to be 30. So what we get is 200 minus 20. So basically the whole thing will equal 230.1 minus 200 minus 20, and we get 0.01. This is discarded, we get only 0. And finally, how do we get the last number? Well, the last number will simply equal the whole number. It's 2301 minus what we need, minus 2300. So again, we take the first number, this time multiplied by 1000, that will give us 2000, minus our second multiplied by 100, which will give us 3 times 100 is 300, and minus the last one, which is the third number, so it's gonna be third times times 10, which is gonna be 0 at our time in our case anyway. So it's going to be, so this will equal 2301 minus 2000 and minus 300. So what we get is 1. All right. Let me show you how that is in action in the code. So when we go to our second digit, what we do is our second digit will equal the value, this time divided by 100, because we are doing, remember, this is always start from a 4-digit number, minus, and when we look at it, we get the first digit times 10. So minus our first digit, which times 10. This is important, the order is important, because we go to first digit, we need to calculate that first, because if we don't, we'll get an error if you try to calculate the second first. Okay, so that's our second. I will do a third, of course, and that's going to be public integer third digit, and once again we will get a return third digit, and we will set a third digit will equal, this time value divided by 10, but we need to do minus first digit times, it was 100, and second time 10, so first digit times 100, and also minus second digit times 10. Now honestly, I like it better with the string method. It was easier to get each character, but this is how you would do it if you actually needed to use the numbers directly. And our fourth digit, and I will do our get, which will return fourth digit, and our set, which will be the fourth digit, equals, remember what it was the value minus first time 1000, second time 100, and third times 10. So a value minus first digit times 1000 minus second digit times 100 and minus first digit, I'll put it in the brackets, first digit times 10. So now we have each digit. Now we can again get the like a decrypted number. So we'll do public string. So our public string, it will return the number in the decrypted number in a string again, because we will be outputting it in the console as a string. So I will do a string final number. I will initialize it to nothing, to empty, and I will do a little a temporary variable of integer. I'll call it temp, because remember we have to swap the digits. At the beginning we swap the first with third, second with fourth, so now I have to reverse that, and we have to of course reverse the calculation as well. So our temp, I will start with the first digit, which, remember, is our first original digit. So it's going to be, so we always start with our third, but this will be output as our first now because we are decrypting it. So I will put that in a parentheses. So it's going to be a third digit. Now we were adding 7 before to encrypt it, so now we will deduct 7. And we have to add plus 10 because we were doing the mod 10. So now we add 10 before we do the mod 10. We still need to do the mod 10 and get the reminder, but we have to add 10 to it in order to reverse the original encryption. This is the formula, basically, how to reverse the before we did the third digit would be third digit plus 7 mod 10. Now we have to do the third digit minus 7 plus 10, and now we will do the mod 10, and that will give us the same number back. So our final number, which is a string, I will add a temp to string, and I will do the same for the rest of the numbers. So our next one, so is the fourth number, which is going to be our second one now in the decrypted. So our fourth digit is minus 7 plus 10. I could simply add, plus 3. Obviously, minus 7 plus 10 is 3. But this way you see how the whole reversion, how the whole calculation is being reversed digit by digit. So now I have that. I will add that now to our final number string, our temp to string, and again now we will do our first digit because that was our original third one. So our first, it's gonna be our first digit minus 7 plus 10 mod 10. And of course I will add that to our string. And finally I will do our, which is gonna be our second number, which is now our last one. So it's our second digit minus 7 plus 10 mod 10. And our final number is now complete. So now I will have all 4 digits in my final number. So all I have to do is return it. So return final number. And that will return already the original number, the decrypted number. So I will do finally our public override string. Oh, that's not right. String to string. And just like before, I will return a string formatted, and I will simply say decrypted number is, and I will pass the number into a placeholder. And again, this time we will call the decrypted number method. Except I will do this like that. So now we can go to our program and call our decryption. So over here, we got the encryption. We output the encryption. Now we need to create the object of the decryption class. So I will create a variable decrypted, which will equal the new decryption class, new decryption class. Now what I'm going to do now, I'm going to pass the result of the method of the encryption. I will pass the encrypted number to it. But since, remember, we are expecting an integer in our constructor now, except over here this is a good thing I looked here because this is not a number. This is now called encrypted number. My bad. There. So we are expecting an integer. So I will have to pass an integer. So I will convert that to integer. And what am I gonna convert? I will whatever the encrypted object returns from the encrypted number method. If you look at the encryption class, our encrypted number returns a string, but our decryption expects an integer. So over here, I call the encrypted number method of the encrypted class, and I'm converting it to integer, and then I'm passing that to the decryption class and as an argument, because that it's expecting, in a constructor it expects an integer. So all I have to do now is console that write line and the decrypted, and the decrypted now should be the same as our original number. So let's test that. And all right, so let's do 3, 4, 5, 6. And this is not correct. The encrypted obviously works. This one does not. We get decrypted number as 3, -6, 5, and 6. Okay, so there will be obviously something wrong with the decryption class. Let me go first digits. If I miss something, it seems to be third, first and second, and fourth is first times 1000, second times 100, and third. Oh, this one says, I have it as first. Oh, this one will be obviously third digit times first, second, and third. I don't know, let me see if that was that. 3, 4, 5, 6. And there you go, actually, it worked. So encrypted number is 2301, and we decrypted it back to 3456, which was the original. Let me run a few more tests. I'll try 1, 2, 3, 4. We got it decrypted correctly. Okay, so we already know that the encryption works, so I'm just checking the decryption. If I start 0, 1, 2, 3, I get back 0, 1, 2, 3 when decrypting it. And now I try with the 0 at the end. So I will start 1, 2, 3, 0, and I get 1, 2, 3, 0. And I don't have to check for the decryption class. I don't have to check if this number is correct. It has to be correct because I am checking that number right here. I'm throwing an exception if it is not. The program doesn't even get to decryption class if the number is not valid at the beginning. All right, so we got a working program. It might be a little confusing, especially when you're dealing with these digits. Like I said, I find it easier to just do the substring. I start with whatever the digit that I need to get from the string, and I will simply add 1 to it in other words, I'm only expecting the 1 digit or 1 character, because it's a string, 1 character back. Over here we did it with the actual numbers, so we did the math. We had to do how to get each of the digits, but it's good to know because sometimes you need to do some calculations within, and you would have to go back and forth trying to convert the values from strings to integers and back and forth. So this way you know how to do it with the actual numbers rather than strings. So now you actually can do it with strings or with the integers, as whatever suits you best. And here we have the decryption method, which we are reversing basically what we encrypted the number with. So, and then we are returning it in a toString method. All right, so it was a little long. I hope it helped you, and I'll see you next time.